Hi, welcome to your lesson on the cosine rule. And check out this great mug. It says y sine over tan. Oh, just cuz. No, that's not just cuz, that's just cosine. Okay, so sine over tangent equals cosine. Let's check it out. We know sine of an angle is opposite of hypotenuse. We know tangent of an angle is opposite over adjacent. So what happens when you divide sine by tangent like we have here? Okay, sine over tangent. Well, that can be said to be this divided by that. So we have this divided by that. Okay, I'm showing division here. We know by rules of fractions, if you have division, you can turn it to multiplication and you invert this second fraction. And now we have an opposite here and opposite here. If you multiply those would cancel. You'd be left with adjacent over hypotenuse. And wait a minute, adjacent over hypotenuse is cosine. So that is why sine over tan is just cosine. Perfect. Now, let's go back to where we were in the last lesson. In the last lesson, we talked about something called the sine rule. It is a rule that can be used to find unknown sides or angles of a triangle when the triangle is not a right triangle. Of course, we began with saying, hey, we know right triangles. We know we can use Pythagorean theorem. We know we can use sine, cosine, tangent. But what happens when a triangle is not a right triangle, like this one here? And we discovered there's this rule called the sine rule that still helps us find missing sides or angles. So just as a reminder, we had the sine rule in two forms. They mean the same thing. But the upper form, we have angles on top, so we use that usually to help us find missing angles in triangles. And the bottom form has the side lengths on top, so we use that to find missing side lengths. It is written in three parts, but we discovered we only use two of the fractions equal each other, depending on what we know in a triangle, and solve. That's the sine rule. Now we're going to discover something called the cosine rule, which is another great rule that is useful in non-right triangles. So let's begin with actually deriving the cosine rule. We're going to begin with one of the toughest parts here. Where does the rule come from? Let's figure it out together. Okay, so where to begin? Well, let's begin like we did with the sine rule by drawing our triangle, non-right triangle, but then dropping a height line or altitude here, because that altitude creates two right angles and we have two right triangles, and those will help us create the rule so that then we can have a rule to use without the height line. So we begin by making the height line right triangles so we can make a rule that can be used without it. Okay, so let's begin in this triangle here. Let's call that h there, and this length x. So with the sine rule, when we were creating it, we began by saying sine of this angle and sine of this angle. But in this case, we're going to focus on the side lengths first and not deal with the angles at all until the very end. So looking at this right triangle here, the bigger of the two, I want you to tell me, or give me an equation for h squared. And notice in the triangle we have no angles. So we're not going to use trig, we're going to use Pythagorean theorem. Can you create an equation for h squared? Okay, well we know x squared plus h squared equals b squared, the hypotenuse. And then rearranging that for h squared, we move the x squared over and we have this. So I hope you came up with that. Now I want you to do that in the other right triangle as well. Another equation for h squared. But we still need to know this length. So let's begin there. How long is this? How long is HB in terms of C, which is the whole length, and X? Well, it is C minus X. I hope you came up with that. Because if the whole length is C and this length is X, then you must do whole length minus this length to get this length, which means C minus X. So now, using this little right triangle, create an expression for, or an equation for h squared. Okay, using Pythagorean theorem again, we have this squared, c minus x squared, plus h squared equals a squared, equals the hypotenuse. Great. Now, multiply this out. Oh, sorry, I moved it over first. And now we're going to multiply this out. Okay, multiply this out and then apply the negative. See if you get the right thing here. Use proper algebra. Got this. All right. So this multiplied out, c minus x times c minus x gave me a trinomial, and then the negative went through it like this. Check your algebra. Now we have h squared equals this, and h squared equals this. So if h squared equals both things, we can equate those two things. And there's my equation combining those two things. So now we have this long equation. What I want you to do now is solve this for a squared. In other words, take all these pieces, move them to the other side. So here's a squared. Some things canceled. The x squared is canceled. Now we're almost at the cosine rule. What we're going to do next is, in the cosine rule, we only want to have the sides of the original triangle. We don't want this little one here, because like I said, the cosine rule is going to apply to a non-right triangle. It's going to apply to the triangle how it was in the beginning without this height line. So we don't want that x in here. We don't want that length. We want to replace it with something. What we're going to do is now we're going to use an angle. So I'm going to do cosine of angle A, which gives me adjacent over hypotenuse, x over b, and then solve that for x to get b times cosine A. Now that will be replacing this x here, and we get this statement here. So notice we have a rule for finding a side by using the other two sides and one of the angles. It has nothing to do with the height and the x's anymore. It is back to the original non-right triangle. There's our cosine rule. Okay, so back to here. We have now the sine rule and the cosine rule, two different rules for finding unknown parts in non-right triangles. So here's the cosine rule we just discovered. And here's another version of it. If we take that rule and we solve for cosine A by moving all these parts to the other side, we get this. So this version and this version are both useful. Please make sure you write down all these rules, and we're going to use them soon. Okay, so just to recap, with the cosine rule, if we have a triangle and we're looking for an unknown side like this, we're going to use this version of the cosine rule, because this is a side, so we're solving for a side. All right, if we have a triangle like this, where we have an unknown angle, we're going to use the other version of the cosine rule, where we have the angle here, and we can solve for the angle. All right, just so you know, just like with the sine rule, we had all these like differing fractions, we could flip them one over the other. We can do the same thing with cosine rule. We can write it with any side as our beginning thing here. And then it changes the other parts here, right? If we have a squared here, then this is b squared c squared, and there's bc again. Main thing to remember is, when you write the cosine rule, if you have the side a here, then at the end you have to have the cosine of the angle that is across from that side. Okay? And if we had b squared here, then we have cosine b here. And if we had c squared here, then cosine c. And in the middle there, the other two sides. And the other two sides here as well. Okay, so that's the cosine rule. And just to note, in the other form, also the same thing. We have cosine of an angle, in this case A, and over here we have B and C, but here the minus whatever side is the matching one to this angle. Okay, so if you can remember that, you'll be able to apply it no problem. Here's our first problem. We have this triangle, and we're going to use the cosine rule to find C, this side here. So are we going to use this version or this version? Well, I hope you said this version, because we're looking for an unknown side. Therefore, you will use the version that has a side here. But this says C in this triangle. It doesn't matter what we call this. You could call this A. Why not call it A? And then it's easier to use the formula. Or if you want to keep this as C, then rewrite these letters and all that to match the C version. So if C squared went here, what would go here? It would look like this. I hope you tried it. If we have C squared here, then right away we have cosine C here. And then we have the other two sides here, AB and AB here as well. Okay, so let's use that. Put in the values you know into this formula. Just pointing out again, if we have C here, then we have cosine C here. That's what it should look like. And then you can solve all this in one step. See if you can punch it in your calculator in one step. And we should get 244. And then take the square root to get C. In this case, C is 15.6. Let's try another one. Here's another triangle given to us. And we know 1, 2, 3 sides of it, but no angles. And it says find angle B. We want to find this angle right here. So now we're looking for an angle. So which version of cosine rule will we use? We will use this one, because this one allows us to solve for an angle. Again, we're looking for angle B, but in this way it's written here, this is angle A. So why not rewrite this using angle B here, and then changing all this around to make sense. If this is angle B, this is going to be side B. Okay, so see if you can write it. It's going to look like this. Check if you had the same thing. Now put in all the values you know into here. So again, just pointing out that angle B here and then side B here. All right, so there's putting in all the values we know. And remember, when we solve trigonometric equations and we're looking for the angle, we're going to have to use an inverse cosine. So angle B is the inverse cosine of all of that. See if you can do this in one step. It's better to punch it in one step on your calculator. So remember, enter a fraction, or first do inverse cosine, So that'll be second in cosine, and then do a fraction and enter all that. And the answer is 58.8 degrees. I hope you were successful. Let's try some more. So try this one here. We are looking for length C right here. Okay, since we're looking for length, we're going to use this version of the formula, put all the values in, solve, and I hope you came up with this value for C. Now try this one here. We're looking for the measure of angle C right here. Since we're looking for an angle, we're using this form. Put in all the values you have, and then do an inverse cosine to solve for angle C, which is 57.9. I hope you had some success. If you didn't, pause and make sure you check all the formula stuff here very carefully. Let's try the next one. Okay, a question students ask is, when do I use the sine rule? Or when do I use the cosine rule? I have these sine rules, I have these. They're both for non-right triangles, so can I use any rule anytime? The answer is no. It depends on what you know about the triangle. So let's show you guys that. You can use a cosine rule when you know this about a triangle. When you know a side, another side, and the angle in between those two sides. This is called an SAS situation. So if you know side, angle, side, you can use cosine rule. Or if you know three sides, 1, 2, 3, side, side, side. So that's easy to remember. SAS, SSS. If you ever see those situations in a triangle, in terms of what you know about them, use the cosine rule. Sine rule is used for all other cases. For example, angle, angle, side, if that's what you knew, or angle, side, angle, or side, side, angle. Okay, these are a little harder to remember, so just memorize this by remembering what you need to know for cosine rule. If you have side, angle, side, or side, 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 cosine rule. Any other situation, sine rule. So now we're going to try some problems like that, where I'm just going to show you a triangle, and you're going to have to decide, what do I know about the triangle, and therefore decide which rule you're going to use, sine or cosine. Here's the first one. Triangle ABC, you're given some things. First of all, see if you can draw that diagram. Here's the diagram you should have. Okay, you're given angle B here, 135. You're given side B is 16, so that's the one across from the angle B right here. And you're given side C is 10, which is across from angle C. That's the diagram you should have. Now find the sides of angle C. Well, first decide what kind of triangle is this. Is this, well, let's take a look. Side, side, angle. Okay, that was not, remember with cosine, it was side, angle, side, or side, side, side. This is not one of those two cases. Therefore, sine rule. Okay, use the sine rule. Okay, sine rule you can set up like this for this one, looking for angle C. And then solve to get this for angle C. Okay, final question. Hence, find the sides of angle A. So it says now you know this angle, hence means therefore, right? So we know this angle, we know angle C. Oh, if you know two angles in a triangle, you can easily find a third because they all make 180. So there is your answer for angle A. Hope you got that. Next one. We have a situation, we have somebody observing, looking at a lake. They know this angle is this, these distances are these, and we want to know the length of the lake. We're looking for CB. So what do you know in this one? What kind of triangle, or what do you know about this triangle? Well, we can see we know side, angle, side. Oh, side, angle, side. Which rule? Cosine rule. Okay, use the cosine rule. Here we go. Setting it up. We're looking for a side, therefore I'll use this version. Put in all the numbers you know, and solve. Okay, that was all very quick, but pause if you need to. Make sure you got the right answer. Okay, here's another one. Read it carefully, see if you can draw the diagram first. Here's the diagram. If you didn't get it right, sketch this diagram now, and now see if you can find the sides of angle X. So first, you're given a triangle, you know side, side, side. That means you're going to use cosine rule. Okay, try cosine rule to find X. We're using this version because we're looking for an angle. Put in the numbers you know, and solve, solve, solve. Here is the measure of angle X in degrees. Okay, here's another one. This one seems the same at first, but there's going to be a little twist to it. Let's see if we can try it. So read what you have there and see if you can sketch the diagram to start. Okay, let's check our diagram here. There it is. Make sure yours is correct like that. We have, I guess we have an angle, another angle, and a side. So angle, angle, side tells us which rule can we use. Well, we're limited to using the sine rule. Now, we can use sine rule to find either PQ or maybe RQ? Which one would be more useful? What are we looking for in this question? Let's see. Find the length of RQ. Okay. But wait a minute. When we use the sine rule, we cannot find a length unless we know the angle across from it. So look, we have 10 and 82 across from each other. So that's good because that's what we need for sine rule. And we have 20 and, oh, we don't know this side. So we can find PQ if we use sine rule. But that's not what we're looking for. We're looking for RQ. So what am I going to do? If I need RQ, I would need angle P. So why not begin with angle P first and then set up the sine rule to find RQ, because that's what we need. So what's angle P? Well, angle P we know, so I set up here, right? RQ is what we need, RQ over sine P. Well, angle P is just the third angle in this triangle, so it must be 180 minus those two. Okay, so angle P is 78. There's the sine rule with the 78 put in, and there's the lengths we need. Okay, check everything carefully. Let's try another one. So read this one out, and again, begin by drawing the diagram and checking if you did it right. So let's check the diagram. And here it is. Double check yours, make sure you have it right. Now, what kind of triangle is this in terms of the information we have? Well, it is SAS, side, angle, side. And if we know side, angle, side, we can use the cosine rule, okay? Try the cosine rule, and we're looking for length of BC. So we're looking for a side length. We're going to use this form, put in the numbers you know, solve, and you should get this answer here. Double check your work. Okay, here's another one. See if you can sketch this. There's the sketch. We are given 3 sides. So we have a side, side, side triangle. What rule can we use? Side, side, side means cosine rule. And it says find the angles. So that means all the angles. Okay, well, pick an angle and let's begin. We're going to use this form of the cosine rule. Okay, to find angle A, I've set up the cosine rule like this. Cosine of angle A, and remember, if we're doing angle A here, we do side A here. So the side across from A, right? 14. And solve that, you should get 91 degrees. Okay, so now we have 91 degrees here. Okay, pick another angle to find. We tried angle B here. Angle B should be 59. And now that you know 2 angles, you can just go ahead and do 180 minus those 2 to get the last one. Here it is, angle C. Okay, good problem. Maybe one more? Yes, there is. Try this one here. First, the diagram. Check this out. Make sure you agree with that diagram based on what you read here. And it says find angles A and B. Okay, what kind of triangle? What do we know about this triangle? We know side, angle, side, so we can use cosine rule. Okay, so cosine rule can set us up to find the length of AB. Let's try that. So we're going to use this version to find the side length, and then solving for AB, this. So now we know this is 9.96. But again, our goal in this problem is not that side, it is 2 angles, angle A and angle B. So what can you do? And remember, maybe now at this point you have 4 parts of a triangle, so maybe you have options. Maybe you can use sine rule and cosine rule, maybe, or maybe not. But the easier is the sine rule. So how about using the sine rule now and finding angle A, let's say. Find angle A using sine rule. So here's the sine rule you could set up for angle A, and if you solve, you should get this. And now you're at the situation where you have 2 angles. Find the third one. Okay, there it is. So you see now that sometimes we use sine and cosine rule to find parts that aren't asked for, but then those parts help us find the parts that we are asked to find. So you need to take several steps. Hope this one worked out. You can do it. You are now a master of sine and cosine rule. And one of the main things you've learned is actually when do you use which rule. And let me just go back to that. Make sure you remember this forever. Recognizing what triangle you have, deciding the rule, and going from there. You can do it. Great job.